Hi, my name's Rachel May, and for my Physics 106 final video, I'm doing image formation of the eye. So if you go up here to the corner, just to get you oriented, here is kind of a full picture of the eye. First you have the cornea, that's what initially bends light into the eye. You have the lens, which will focus the light, kind of the body of the eye, and then the back, the retina, where light and image formation is actually processed. So here we're going to go to a bigger version, basically. And if you've noticed, I have left the cornea out. Though the cornea does bend the light, it's not very significant and you can kind of just ignore it for our purposes. So here we have the lens. The lens is a convex lens. As our professor said, it's bulging out, so convex. And it can also be described as a thin lens, which means we can use that equation 1 over d naught, do, plus 1 over di equals 1 over f. So let me remind you or describe these different terms. So do is going to be the distance of the image, do for object, is the distance of the object to the lens. Di is going to be the distance of the image from the lens. And then the focal length, or f, is the distance that it takes for this light to converge onto one spot. That one spot is called the focal point. And in our eye, the focal point is always going to be on the retina because that is where we want to have our sharp image. Something else that is interesting with the eye is that di, or the distance of the image, does not change. Because if you think about it, your eye cannot get fatter or thinner. Your eye has a set shape, which means the distance of the image also always has a set distance, which, if you are curious, is usually about 1.8 centimeters. So if you notice, this is a case 1 situation. That means the distance of the object is always going to be greater than the focal length, which, if you think about it, is true. Usually when you're looking at something, it's about a meter away. And our eye is definitely not a meter long. The fact that this is a case 1 situation also means that our image, you want to call this the height of our image, is actually going to be flipped. So the image on the eye would actually be a little upside down man. Luckily, we have a pretty smart brain, and it will flip the image back and correct it for us. So you may be wondering, if the distance of the image cannot change, how do we change the distance of the object? Or how do we look at things that are far away? Or how do we look at things that are closer? We do that by changing the focal length. And changing the focal length is something called accommodation, which we will discuss in the next part of the video. So now we're going to talk about the physics of accommodation. Accommodation means trying to see things that are farther or closer to you. So I've kind of rearranged our classical formula here, where we have 1 over d of the image equals 1 over the focal length minus 1 over di. So remember, the distance of the image is fixed. It cannot change. And I have that distance of the image right here. It's always about 1.8 centimeters. Every eye is different, but that's about what it is. That means in order to get a different distance of the object, or be able to see something farther or closer, you need to change your focal length. And how the focal length is changed is by changing the thickness of the lens. Here you can see this is a thick or a fat lens, and this is a very thin lens. When you have a very fat lens, the focal length actually decreases. You can see over here that when you want to see something close up, let me write that down. This is if you want to see something close. This is if you want to see something that is far. So if you want to see something that is close, like about 1 meter, your focal length is actually a little shorter. It's about 1.77 centimeters. However, if you want to see something farther away, the lens will actually get thicker. It gets thinner, increasing the focal length. You can see here to see something 3 meters away, something farther away, you have a longer focal length, about 1.8 centimeters. You can see if you want to see something close, the focal length of the fat lens is going to be, smaller than the focal length of the thin lens. This also makes sense in the power concept. So the power of a lens is 1 divided by its focal length. And a more powerful lens can see things that are closer up. So for example, you may hear that's a powerful microscope. That's because the microscope can see things that are very small. And by decreasing the focal length, you are making the lens more powerful. And by increasing the focal length, you are making the lens less powerful. So now we're going to talk a bit about how the lens actually changes its size, because I think it's a pretty fun concept to learn. All right, so we're going to talk about kind of the anatomy or the physical part of accommodation, just because I think it's really interesting, so we'll go over it really quickly. So here in the eye, you can see there are 2 muscles that are attached to the bottom and the top of the lens, and these are the muscles that make the eye either thick or thin. You can see there are these little strings that are attaching to the lens that are going to pull or relax the lens. If you're curious, these are called ciliary bodies, the muscles, and these are called the suspensory ligaments, as in they suspend the lens. So when you have a thin lens, the muscles are going to be relaxed. So just like when you relax your arm, your muscle is going to be nice and thin, nice and relaxed. However, this means that the little strings are going to be taut and very tight. So this is going to be pulling your lens and making it nice and thin. So because your eyes are in a relaxed state, that means you can usually look at things from a regular distance or far away pretty easily. However, when you want a fat lens or you want to look at something that is close to you, the muscles contract. So instead of being nice and flat, they're going to pull up into these nice tight balls, just like if you flex your bicep gets shorter and thicker. And that's actually going to make these strings very loose. So your lens will be able to relax and become fatter. Your lens actually wants to stay in a thicker size than a thinner size. So that makes your focal point shorter or your focal point longer. This is also why if you're reading or you're looking at something up close, your eyes can get tired, because you're you are flexing these muscles. It's just cool, I think, that when you're flexing, it's loose, versus when you are relaxed, it is actually pulled tight. So now we're going to talk about a couple disorders and where things can go wrong with the eye, and that'll be it. So there are 2 common conditions that usually happen for the eye. The first is short-sighted, and the other is far-sighted. So first, to talk about short-sighted. Short-sighted is when the lens is too powerful. That would make your focal length shorter. Or it is when the eye itself is just too long. Both of these things result in a focal length, right here, that converges the light before it hits the retina. So again, if the power is too great, you have a short focal length. Or if you have a normal amount of power, but your eye is too long, you get all the light converged right here. This is going to create a very fuzzy image on the retina. Farsighted is the opposite. This is when the power of the lens is very small, you have a weaker lens, or the eye is too short. Both of these result in a longer focal length. Again, if it's too short, the focal length, if it's normal, would be too long. Or if you don't have enough power, you cannot converge the light onto the retina. This results here in our focal point being behind the eye. So again, we will not have a clear image right here on the retina. So there are a couple of different corrections you can use for this. The first one is LASIK. What LASIK does is that cornea, kind of the entrance to the eye, is shaved off and reformed. And this changes the way light is bent and enters the eye and can help correct vision. The other and probably more common way is glasses or contacts, kind of the same thing. Here's a little eyeball. Whoops, anyway. So if you are farsighted, you will want a converging lens because you need to converge light to kind of help out your lens because it's not powerful enough. And that will be a convex lens. Here you can see the light is converging. If you are short-sighted, that means your lens is too powerful, it's just too good, so you need to make it almost harder to see. And you'll do that by diverging the light. And to diverge the light, you will need a concave lens. So if you feel on your glasses, you can see if you have a convex or a very round lens, that means you're farsighted. Or if you have a lens that is bending inward, a concave lens. And that's it. Thanks for watching.